Our first speaker of the night is Gavin Grim. Gavin is a senior here at Quinnipiac University, majoring in industrial engineering. Gavin is a member of Eta Phi, the Institute of Mechanical and Systems Engineers, QU Rock Climbing, and PEPFAM. For Gavin, everything needs to have a sort of flow, and that includes his passion for mechanics of cars. Through his talk, Gavin will instill purpose in his passion by discussing how artificial intelligence will always need the human perspective. So, everyone please join me in welcoming Gavin Grim.
Thank you, Mark. Good evening, everybody. Can you guys tell me what this shape is behind me? Circle. Great, I'm so glad you guys all got that right. A little nervous for a second. But the reason there's a circle behind me is because a circle is meant to represent a wheel. The wheel is arguably one of the most important inventions we've ever had in human history. Revolutionized the way we travel in terms of speed, efficiency, duration, and carrying more weights. It was arguably the biggest invention that aided the human experience. Formally from about 6,000 years ago, when the wheel wasn't officially invented, there's been millions upon millions of inventions that have all been made with the same goal, to aid in that human experience. That's very key. They've all aided in that experience. But as we see today, more and more inventions are being made with the idea of trying to take away that human experience. The wheel did not get rid of the traveler, just let us go further, helped us out. But we see again, our purpose and goal for these inventions are just now changing to one where we're going up for speed and efficiency that strips away the very purpose of what makes the process worth doing in the first place. Over the past 2 years, I spent my free time working to rebuild a once working racing simulator in the industrial engineering lab. This simulator worked on my orientation, but by the time I got to school here, it bricked. The PC died and components, who knew where they were at. So I sat there in the corner collecting dust for 2 years until I finally decided to turn it back on. I turned it back on with the goal of bringing it back for racing games and promotional events, but when I went for my funding request to school, as you can imagine, they shot that down. It's not for academic purposes. So I had to come back and either design labs for every single class that industrial engineers take, or do research. I decided to do the research option. I wanted to research something that I was passionate about, and something that not many of us even know about today, but as it becomes more and more used, becomes more and more used, will affect more and more people. In this search, I discovered steer-by-wire technology. Steer-by-wire technology takes away the steering shaft. It goes from the wheel to the linkage, which essentially just turns the tires, and replace it with motors, sensors, and computers. But the byproduct of this is, there's no more physical connection to all the forces you feel. So if you're driving on Connecticut Road, as you all know, hit a pothole, your wheel shakes. So that's no longer a part of the system. So I want to see, is that feedback something that's just inherently part of the mechanical system? Or is it something that humans actually need to operate with the vehicle? So as I found, as you reduce that feedback, going to zero, humans become less intertwined with the car. This is something we all felt before. Imagine driving into any sort of modern car, all the climate controls are behind 3 different menus on the screen. If you want to change your radio, you got to go through, there's no more dialing, or just change the knobs. You got to see the slider or go through a menu. But this also made great inventions. On the highway, it keeps you in your lane, adaptive cruise control, so you don't hit a car in front of you. But this is a quote from a AAA FTS study that looks at this interaction. It says, behavioral adaptation which may begin to occur, and over-reliance and over-trust in the automation features potentially develop, including a greater willingness to look away from the forward road. A greater willingness to look away from the forward road. Again, as Mark said, I am an engineer after all, so we're going to do a physics problem. Ooh, physics scary, but don't worry, I'll walk you guys through. Pretty standard equation, speed equals distance over time. We're going to rearrange that to solve for distance. Distance equals speed multiplied by time. So imagine driving on a highway, we're going to be going 55 miles an hour, that's the speed limit. We don't speed, so not 1 mile an hour over. And let's say you're on your morning commute to work, and you've got 10 minutes into the drive. So you want to change your podcast, go through the settings, go find a thingy, go do that. And now that your car is warm, say it's in the winter, you wind up turning the temperature down at your butt's a little warm from the heated seats. So let's say it takes 5 seconds. It took me a lot longer to explain that than it would actually do, but 5 seconds we'll say. And In that time, you drove 403 feet. Pretty arbitrary number, doesn't really mean much to any of you, but that's the length of an American football field. So you just drove the length of an American football field, not knowing what's going on in your surroundings, relying solely on the technology. Is that a bad thing, or is that just how we've adapted as humans to being in a system? I think the world goes a little bit better if we interact with the world around us. But that's not to say that technology can't aid humans. My favorite example of this technology with humanity is in Formula One. Arguably the absolute pinnacle of motorsport, these cars are filled with tens of thousands of sensors, streamed data points after across the world to a room this size filled with engineers with 6 monitors all drinking their monster drinks because they're up at 2 in the morning doing simulations for the track. The car can basically drive itself, and the other whole series really do. But in this sense, there's still a human driver strapped in that cockpit, flying down the track over 200 miles an hour, taking a turn at 5 times gravity. So imagine you're laying on your side in bed, and you have 5 people laying on top of you. It's a lot of weight. No one wants that. But why is there a human there in the first place? The human is able to do something that can never be automated. To emphasize this, I'm going to read through a little excerpt from Lewis Hamilton, who's arguably the greatest Formula One driver of all time, and his race engineer at the time when he that Mercedes bought it. Lewis says, "I'm slipping everywhere on entry, car is so unstable at high speed, I can't trust the rear." So what this means, imagine driving on the highway in the snow or the rain, something where the track isn't as grippy for a normal car, and you go to turn, and you feel a little jolt. You don't feel stable, you're not really connected with the ground. That's not very good when you're going very, very fast around these corners. But his race engineer comes back and says, "Copy Lewis, we don't see anything unusual in the loads. Balance looks consistent with the model." Again, Lewis, best Formula One driver of all time, I would trust his opinion, but he comes back and says again, "The model is wrong, then. I'm telling you, the car is moving, I'm going to catch it every single lap." But they're doing something over and over and over and over again, and the person who you're supposed to trust the most is telling you you're wrong. So again, his engineer comes back and stays on and says, "Copy that, keep an eye on it, for now everything is green, stick with the plan." Imagine you're on the phone with a friend, driving in the snow, and they say, and you tell them you're slipping. You don't feel stable in the snow, and whenever you turn, the wheel doesn't necessarily grip as it should. And your friend says, "No, you're not." The only communication he has with you is through that phone. He can't see what you're doing. And you tell him, "No, I'm slipping, I'm looking at bushes, the road goes left." And they say, "No, you're wrong." Like, it's a really frustrating topic. But what this means in the context of this example is that there isn't a sensor in the place where the problem is occurring. A machine is blind to tell you if a problem is occurring, it's not even looking at that location. If I'm looking over here at a problem, and I'm looking over here at the sensor, and the problem's over here, sorry, whoever it's pointed at. And I'm only seeing here it's in green. The problem's over here, I'll have no idea that it's ever even happening. But that's why the human's in that car. The human is able to feel something in their spine that a sensor can't pick up. They can hear a change in the harmonic of the engine. They can see something the camera angle is just not wide enough to see. The human is the bridge that gives the context to all these sensors. We see something like this in every single industry, every single application. My research into steer-by-wire showed to me that if you're seeking performance and optimizing your speed, one setting is best for feedback. But if you want to minimize your mistakes, a whole completely separate setting is best. And not even looking at data at all, just by sitting in your car and saying, what do I feel the most comfortable with? A third setting is completely best in general. So every use case and every user has nuance. The allure of this frictionless world that we're trying to create is strong, don't get me wrong. I use AI to do this very speech. I'll do a little bit of flow at the beginning, trying to consolidate my ideas, the spelling, the grammar. But as we've seen time and time again, and through that example, you see as you take the driver out of the car, you no longer feel that sensation in your spine. The sensor cannot pick up on every single thing. I challenge you guys to go, once we all leave this room tonight, think about how you interact with the world around you. Are there areas that automation would be great? Or are there areas that automation would take away the human experience? I know for all of us, there are these elements. I want you to think, a computer can give you all the data in the world, give you millions upon millions of data points, but you're all the only ones that can give that data meaning.